Okay, so good morning. Okay, so I want to say good afternoon to my friends and lecturer. Today I'm gonna show you how to design a distribution system for insulator using a MATLAB Simulink. So let's get started. Open your MATLAB and click the Simulink. So just skip the part because yes, my laptop is having a big problem. So click this create model, and then this. Okay, from here, first step is we have to save first. So, okay, DW6, don't forget to underscore, so you will be able to save your matrix number. Alright, so based on the calculation, which is the example here, part 1, this is the calculation for voltage distribution over 3 insulator and string efficiency without. This part 1 is without the shunt capacitance. So this is the example question. The overhead line is 33 kV. Alright, we're supposed to get this as the total voltage 19.05 kV. So this is the calculation, theoretical calculation. Right. As we can see here, it says that V1 is equal to V2, V2 is equal to V3. So the voltage for the three of the this is same, which is 6,350 volt. This is a mistake because there's no K, just 6,350 volt. So the percentage supposed to be 100 is because it is without shunt. This formula. So let's get started. First we go library and then we find AC voltage source, double enter. Make sure you click the black and white and not the colored one. AC voltage, right click and add to model. Okay, check it here, and then we find ground. Enter, find, scroll down and we can see this ground. Alright, so the next is RLC branch. Okay, to rotate, we click Ctrl R. We setting it first. We choose capacitance or self-capacitance, and then here we put. We don't change anything. So we need 3 because there's 3 volt. So just copy and paste. Right here. Okay. Connect the wire. Alright. The wire. We need another ground here. Okay. So don't forget power GUI. This is very important. So we are able to run without any error. Here. Alright. Okay, so we completed the circuit. So if we want to find the value, we have to add RMS. If you cannot find, go to same scale, electrical, sources. Oh, special power system, sensor. Okay, here it is, RMS. RMS. Um, we have to find um, voltage measurement. Alright, add to block. Okay, then we click the library browser again, we find display. Make sure this is the correct block display. Okay, correct. So add the wire. This is in parallel, so we connect it as parallel. I misclick this. Sorry, I misclick. So connect the wire and parallel. Copy and paste. Copy and paste. Alright, so let's test. Let's run. Oh, it's so there's an error. It says we need to add the resistor. So we copy here, right click, and add resistor. So just leave it default setting. I think we can okay. We try and edit. Alright. I think that's all. We run it, right? Oh wait, we haven't configured. Configure here. So in this part, you can either use the final value, which is 26.93, but for me, it's not really give the final accurate value. So instead, we can put formula 1.414 multiplied by 19.5 kV D3. Alright, so leave it 0. The frequency is 60. Apply, okay. And let's see. Alright, so we get the value. Okay. The theoretical value is 6350 watt, but we managed to get almost as the theory value. So I think this is correct. So we have to create a circuit for string efficiency and total voltage. So just add this. Run it. get the value. So given method. So go to library browser and then add this block and also gain. We need gain. Alright, get this to block and then we put it here. Right here. It is alright. Connect the wire as is. Copy this. We need gain, so change it to 100 so we can get the 100 percentage. We put million or 3, so we put 3 here. This one we connect to voltage number 3 because it says here voltage 3 times voltage 3. Alright, so we run. Okay, we compare the theory value. So we get here 100 correct, 6350 correct, 19.05 kV. Alright, correct. So change here string efficiency. Alright, string efficiency. So you can see without the shunt, the value for 3 of the voltage remain the same, and there's 100 percentage for the circuit without shunt. So now we can screenshot. Alright, yeah, first we uh, screenshot now. Make sure you include the name so people know that it's yours. Alright. Okay, done for the circuit without shunt capacitance. So now we move on to the circuit with capacitance. So capacitance, we just copy here, Control R, make sure it's facing this way. Capacitance from the capacitance value is 0.22. Alright, that I think that's all we need to change. 0.22. We just put it this way. And drag here. Alright, okay, we connect the wire like this. Copy. And then connect the wire. Alright. Double check. I think okay. So we try to run. Okay, so we compare the theory value. Okay, with the shunt capacitance, we can see that our top voltage is become the lowest and the middle value, which is 5000, and the bottom is the most highest value, which is 8320. Okay, so the total voltage remain the same, 19.15. So how to calculate it? How to calculate this is by we add these three all together, which is I think from my calculator we get we get 19.04. I think this one correct, total voltage. And for the string efficiency, we can see that it is also correct, which is 76.96%. So this is the circuit for shunt resistance, and just now is the without the shunt resistance. So I can say that we have successfully managed to complete the circuit, so you can snipe into and put in the practical work. Sorry, it's a bit slow loading because my laptop is very slow, quite slow. Alright, just put it here. This without the capacitance. This is with the shunt capacitance. So I think that's all. Thank you. Thank you for listening and your patience. So I hope you understand, and that's all. Thank you.